yesterday, you guys watched a Desmos, or interacted with a Desmos lesson, reviewing basic things about slope and lines. Right? Did you guys have any questions about anything from that? Did it go pretty well?
Yes. I like that activity we did yesterday.
You liked it?
I liked it. It was nice.
I mean, I think it works really well. The only problem is it takes a lot of time for me to make something like that, so we won't do something like that too often.
Like every day. The whole year, and then like do all the other people do it over and over, and then we just copy on the
Well, you do it every day, so like your lesson plan.
I prefer it like this.
And then,
I mean, we might mix those types of things in every once in a while. It's just it takes a lot for me to make something like that.
a lot of work, but it's a lot of
Time.
You don't have time though, so you
You're not using your brain as like just stop. You're very.
Nice.
I'm not, but I'm positive. I'm loving it.
All right. So today, then, we're going to take that one step further and talk about parallel and perpendicular lines. So, did you guys talk about parallel and perpendicular in algebra?
Yeah.
Yeah. All right. So hopefully this will be pretty straightforward then. So two lines have the what slope? What's the relationship between slopes of lines that are parallel? They're exactly the same, right? And if two lines are perpendicular, what's the relationship between their slopes? Opposite reciprocal. So what does that mean?
they go through each other.
Okay, yeah, so in terms of like the actual graph, perpendicular means they're going to meet at right angles, right? But in terms of the slopes, what does opposite reciprocal mean? Okay?
So if you had a slope of 1/2, it would be -2/1.
Right. The opposite part means change the sign. So one's positive, one's negative. And the reciprocal part means flip the fraction. So what's the reciprocal of -4? Positive 1/4, right? Because we have, this would be the same as -4/1. How about the reciprocal of 3/7? -7/3, right? So these would be examples of perpendicular slopes. So on your paper, I think I deleted this part on your paper. It just asks you to find the slope of AB and the slope of CD and determine whether they are parallel, perpendicular, or neither. Right? So ignore what's up here. Go ahead and calculate those slopes real quick. Between A and B, and then between C and D. Right? So you're calculating the slope between these 2 points, and then separately the slope between these 2 points. Okay? And determining if you get the same slope, opposite reciprocal slopes, or if there is no relationship between them.
Okay. 3 and 1 half. So you another. It's only put some more. Huh? No.
So did we get slopes of 3 and 1/2? Okay, 3 or 3/1. So those are obviously not the same, so they're not parallel. They're not opposite reciprocals either, so they're not perpendicular. Another way, instead of thinking about opposite reciprocals, another way to think about perpendicular is if you multiply the two slopes together, they would be -1. Right? If you multiply opposite reciprocals together, you should get -1. So you can also think about multiplying the slopes together. If you get -1, they're perpendicular. Right here, they're neither. Right? This would be the graph of those two lines. You can see that they're not parallel, but they're also not perpendicular. Right? They don't meet at a right angle. Right? So let's jump down to the exercises then, and in numbers 1 and 2, well, actually, in all 4 of these, we want to determine whether these two lines are parallel, perpendicular, or neither. So we just did an example like 3 and 4, but if I'm given equations of the lines, how would I determine whether those two lines are parallel, perpendicular, or neither? Put them on Desmos. Okay, so yeah, I mean, we will have access to Desmos, so I mean, that's absolutely, I mean, if you get a question like this, you can just put those into Desmos. Like, so yeah, if we don't want to get Desmos out, we can just look at the slopes. What are the slopes of these two lines? 3 and 3, right? Because remember, if we have a line in slope-intercept form, okay, y equals mx plus b, m is the slope, and b is the y-intercept. So these are already in slope-intercept form, so I can see that both of these have a slope of 3. So what does that mean? They're parallel. About number 2. They're both in standard form. So what does that mean? So what do I have to do? Put them into slope-intercept form, right? So that basically means solve for y. So go ahead and do that for both of those. Solve both of those for y.
There's so much.
I'm not gonna worry about the TPA course because he doesn't talk about it. But you should ask him about it. Ask him if we're like what it's doing.
So for number two, I think we should get slopes of 2/3 and negative 2/3. So that would be neither, right? They're not the same. They are opposite, but not reciprocals. So these would be neither parallel nor perpendicular. Right? Why don't you guys take a minute or two here and try 3 and 4. Okay, these are just like the example that we just did, where all we're doing is finding the slope between M and N and the slope between R and S and comparing them.
No.
Yeah. Chad.
No.
Shut up. You know what?
We couldn't.
Yeah. Well, anyway.
It's not only two
Is there any size of it? How many sides do you have? You have any sides of it?
She's a big project.
Oh, yeah, she gave us
She could get here first. You can make it. You have the choice.
You call that to do this. And you transfer it to take it off. So divided by negative one. Because we divide negative one by negative, this is positive.
She gives us ingenuity. She's just like an idiot.
Yeah.
Oh, no, I said.
And why do you feel over it?
Said she like. No, it's just dumb.
It's a parallel. She shouldn't make your own way. She wants to be right.
She's trying to solve it.
I guess that would be fair.
That's my
Yeah.
What does that mean? This is positive.
So for number 3, I got slopes of positive 1/5 and negative 1/5. Is that what you guys get? So that would be neither, right? They're not the same, and they're not opposite reciprocals. For number 4, I got slopes of 2 and 2, right? Or if we want to write them as a rise over run, we could write it as 2 over 1 and 2 over 1. So what does that mean? Parallel, right? They're exactly the same. So that would be parallel. Okay. We okay with that one? Alright, so then on the back, we want to write equations of lines that satisfy certain conditions. Right? So first, okay, we just want to write the slope of a line, or I'm sorry, the equation of a line that has a slope of 4 and goes through the point 6, 2. So we have two equations. We have two basic forms of equations of lines that we use, right? Y equals mx plus b, and y minus y1 equals m times x minus x1. Right? This is slope-intercept. This is point-slope. So here, for number 5, I'm given the slope, and I'm given a point. So which equation would make the most sense to use here? Slope-intercept or point-slope, if I'm given a point and the slope? I mean, technically we could use either one, but if we're given the slope and a point, it probably makes sense to use point-slope form. So the directions here say write your final answer in slope-intercept form. So yes. So to do that, right, the slope is our m value, and then our point is x1, y1. So I'm just going to plug those three values into y minus y1 equals m times x minus x1. So I'll have y minus 2 equals 4 times x minus 6. Now, sometimes this would be an acceptable final answer. Okay? If it just says write an equation of a line, this would be fine. Here it does specify, though, to write your answer in slope-intercept form. So here we do have to solve for y. So to do that, I would distribute the 4 through. So 4x minus 24, add the 2 over, and we end up with y equals 4x minus 22. Now we could have done that using slope-intercept form as well. Okay, we could have plugged our m value in, our y value, and our x value, and then solved for b. Okay, we could have done it that way as well. I guess I'll go ahead and do it that way too, just so you guys know that you have options here. Okay, so I could plug 2 in for y, 4 in for m, 6 in for x, solve for b. So I get 2 equals 24 plus b. Subtract 24 over. We end up with b is negative 22. So then, to write the equation of the line, we would say y equals 4x minus 22. So we get the same answer either way. Okay? But it's a good idea to get in the habit of using this, okay, if we're given a point and a slope, because sometimes this is an acceptable final answer. So you save yourself a little bit of work. Okay, as long as you read the directions. Okay, if it just says write the equation of a line, this is okay. This is an acceptable form of a line. But if it specifies write it in slope-intercept form, then we do have to solve. Okay, you okay with that one? So now the next few are writing equations of parallel and perpendicular lines. So for number 6 here, it says write the equation of a line that goes through this point and is perpendicular to this line. So we still need the same two pieces of information that we had up here. We still need the slope and a point. Well, I have a point. How would I get the slope of my new line if I want it to be perpendicular to this line?
You have to put it into the y equals 9 form, and then you get the slope then.
So yeah, first step is to put this into slope-intercept form so that we can see the slope of this line. So to do that, we'll solve for y. So subtract 2x over here. 3y equals negative 2x plus 12. And then divide everything by 3. So we'll get y equals negative 2/3 x plus 4. So what's the slope of that line? Negative 2/3. So what's the slope of my new line that will be perpendicular? Positive 3/2, or 3/2, maybe. Alright. Yeah, so, or 3/2. And I want the opposite reciprocal of this because I'm told I want the line perpendicular. So, the information that I have now is m equals 3/2. I want this to go through the point 8,5. So now, we're basically doing what we did on number 5. Okay, we just had one step before that to gain the information that we needed. So, I'm going to go ahead and plug this into my point slope form of a line. So y minus 5 equals 3/2 times x minus 8. Are you guys comfortable multiplying fractions? I mean, yeah, you guys will always have access to a calculator, but say it again. Yeah, 3/2 times 8 would be 12. Yeah. So to do this by hand, okay, and I mean you guys are an honors class, so I feel like you should be comfortable multiplying fractions. To do that, right, we just set this up as a fraction times a fraction and multiply straight across. So 3 times 8 is 24, 2 times 1 is 2, 24 divided by 2 is 12. Well, when you're dividing fractions, so if we had like 3/2 divided by 8/1, we would just rewrite that as 3/2 times the reciprocal. Cross multiplication would be if we had an equal sign in between them. Like if we had 3/2 equals x over 5, something like that. That's where you cross multiply to solve. Alright, so this is minus 12, and then to solve for y, just add the 5 over, and we get y equals 3/2 x minus 7. So this line goes through the point 8,5 and is perpendicular to this line. You okay with that one? Now, when we take a test on this stuff, I mean, even on the air test, since you have access to Desmos, it would definitely be a good idea to graph both of these and see that they are perpendicular, right? Just to double check yourself real quick. Right? So the last two examples here, we're doing something similar. So we want, for number 7, to write the equation of a line that passes through C and is parallel to some line LB that goes through these 2 points. So how would I do this one? Okay, so again, we need the slope and a point. We have our point. How do I find the slope of my new line? Marissa? Find the slope of LB. So, go ahead and do that real quick. We get 3/5. So what's the slope of my new line going to be if I want it to be parallel to this one? The same, 3/5, right? So I want a line that goes through this point, the slope of 3/5. So y minus y1 equals m times x minus x1. My y1 will be 5. So y minus 5 equals 3/5 times x. Now, this is a negative value, right? So I'm going to have x minus -2. Or we can go ahead and just change that to x plus 2. Right? So be careful there. Whenever you're plugging in a negative value into either x1 or y1, that you're subtracting a negative value, which would just be the same as adding. So now distribute this 3/5 through. So that'll be 3/5 x. What's 3/5 times 2? 1.2 or 6/5, right? Plus 6/5. Then subtract the 5 over. And we get y equals 3/5 x. How do I do 6/5 minus 5? I'm hearing lots of different answers.
Wait.
I would add 5, sorry. I messed that up. Okay, but then put it on the back of it? What do you mean?
Add it to the top.
Oh.
No, you have to.
Right, so if we want to do this by hand, we need to have common denominators. So if I want to do 6/5 plus 5, I need to change 5 into having a denominator of 5. So yeah, if I want to get common denominators here, I need to write 5 with a denominator of 5. So to do that, okay, if we're thinking, well, this is the same as 5/1, to get a denominator of 5, I need to multiply the top and the bottom by that denominator. So this would become 25/5. So now when we add, we just add the numerators, right? We don't add the denominators. So this would be 31/5. Yeah.
This is 1 off, minus 1 off. 6. So I did it 5 and 1/5. Or 6 and 1/5, sorry.
Yeah, that would be another way to think about it. We could say this would be 1 1/5 plus 5 would be 6 1/5. Yeah, that would work. So, just one more on here. I want to write the equation of a line that goes through this point and is perpendicular to this line.
Same thing, you just make the slope.
Right, so I want perpendicular. So I want to take the opposite reciprocal slope of this line. Amber? So, yeah, we normally would think we want to put this into y equals mx plus b form, right? But, Braden, why don't we have to?
Because the slope is right there.
Right? Even if it's in point slope form, we can still just see the slope. Okay? Really, the only one that we have to change into slope intercept form is if we're given it in standard form. Even if we're given the equation in point slope form, I can still just see the slope. Right? The slope of this line is just 3. Its most practical application is word problems. Like solving systems of equations, things like that. So, what would be the slope of my new line then? -1/3, right? If I want it to be perpendicular to this line, take the opposite reciprocal. So, I've got the point 4, -3, and my new slope is going to be -1/3. So I'm just plugging that information into my point slope form. So y minus -3 would be y plus 3. equals negative 1/3 times x minus 4. So y plus 3 equals negative 1/3 x plus 4/3. So negative times a negative. Then subtract the 3 over. And we'll get y equals negative 1/3 x. What's 4/3 minus 3? Yeah, so if we multiply top and bottom by 3 here, this would be 4/3 minus 9/3, right? So we get negative 5/3 minus 5/3. Any questions over